Chemical engineers design processes and we make things that we all need. And what I'm going to talk to you today is basically how important chemical engineering is, and you might not have realised, okay? Chemical engineering is everywhere. It's what I'd call ubiquitous. You can't go through your life without encountering the things that chemical engineers have made for us all. So you might not have much of an idea what chemical engineering is. You might not have much of an idea of what chemical engineers do. But it's really, really important. And if anything else, if you don't take anything else away from today, hopefully you'll know what chemical engineers do and you'll understand how important it is. Okay? So as an example, so what we're saying here is that chemical engineers design processes to make the things that we all use every day. Okay? So as an example, who washed their hair this morning? Yeah, who used some shampoo? Okay? Chemical engineers are involved in designing the processes that we use to manufacture shampoo. And they're also designed in how we actually design the shampoo. I don't know if you ever thought about how shampoo is designed. You might, if you're curious, and you might have looked on the back of a bottle of shampoo and looked at the ingredients. Anyone ever read what's in a bottle of shampoo? One of you will admit to that. Well, that's something the rest of you can do the next time you all wash your hair. Okay, if you have a look at the ingredients, and you might think about what's there and what that means. So the ingredients, the things that we put into different products, shampoo in this case, when we're talking about the recipe we use as chemical engineers, we call it the formulation. So how we formulate our product, what ingredients, what things we put in there. Have you ever studied anything about chemical reactions? You know what I mean when I say chemical reactions. So when I talk about taking raw materials, okay, and turning them into products, which is what we've said chemical engineers do, in order to do that, there has to be a chemical reaction. Okay, what happens to turn that raw material into our product? Okay, so we have to have chemical reaction happening. And so one of the things we'd have to do as chemical engineers is understand the chemistry. Okay, understand the chemical reactions, understand things to do with ionic bonding and how all that works. Okay, so all this chemistry you're learning, we use in chemical engineering. And this is probably the only, this is the most technical two words I'm going to use. So as chemical engineers, we call those chemical reactions that happen, the things that change our raw materials into our products, we call that a molecular transformation. Okay, so that sounds really complicated, but all I mean by that is there has to be some sort of reaction happening, okay, to turn raw materials into products. So I'm actually a biochemical engineer, so I don't work with chemical processes, I work with biochemical processes. So as an example of a reaction that I might be interested in, we could turn glucose, sugar, into ethanol, into alcohol. Okay, so fermentation we use a lot when we make bread, things like that, and this is using yeast. Okay, so we've got molecular transformation, so this is the thing that turns our raw materials into our products. So an example might be, if I've got a barrel of crude oil, and that's our raw material, who might want to buy a barrel of crude oil off me? Anyone wants to buy a barrel of crude oil? You do? Okay, what would you do with it?
Use it for my car.
Use it for your car, but what would happen if you put crude oil in your car?
It wouldn't mix with it, you'd have to...
Yeah, you wouldn't get very far. That's for sure. So, yeah, go on, what you have to say? You have to refine it, exactly. And so that's what chemical engineers do. So if I come along and say, rather than sell you crude oil, I've got some petrol to sell you, who might want that petrol? Would more of you be interested in buying some petrol from me? If the price was right, yeah? Some nods. Who would want petrol? Go on, show me your hand so we can see. Yeah, more of you, right? And so what we're actually doing there as chemical engineers, so as you said here, we design an oil refinery. Sounds simple, it's very complex. But we design an oil refinery and that'll transform, we'll carry out some chemical reactions, and in this case lots of different very complex chemical reactions, and we'll turn that crude oil into petrol so you can put it in your car. We turn it into plastics and lots of other things as well. And what we're doing there as chemical engineers is we're doing one other key thing that chemical engineers do. We're adding value. So what that means is we're actually making things that people want and will pay money for. Apart from one person in the corner here, so I'm picking on you, who would want to buy some crude oil, the rest of us probably don't really want it, so we're not going to pay money for it, whereas you're going to want to go and put petrol in your car. So what we're doing there, we call that adding value, basically making things that people need and will pay for. So as chemical engineers, we come along and we say, okay, the chemist can do this down here in a test tube. I'm going to carry out those same reactions, that same molecular transformation, that thing that turns our raw materials into our products. I'm going to carry out that, but at large scale, so in my 5,000 litre reactor. And so I have to understand a bit about the chemistry that happens. how to be able to communicate with the chemist, so communication is important. But then I have to understand lots of other things as well. And I use a lot of maths to understand these other things. So to design a large-scale process, I have to understand things like how heat moves from one place to another. So in physics, have you learned anything about heat? So what have you learned about heat in physics?
Conservation of energy.
Conservation of energy. And what do you know anything about how heat moves around?
It's harder for it to move through gases and liquids than it is for solids.
Yeah, and if I say things like convection and radiation and conduction, have you heard of those terms? Yeah. So all of that, we take that from physics and we describe that mathematically. Okay, so the maths that we use for that you won't have learnt yet, I don't think. If I say differentiation, does that mean anything to you? No. Okay, I didn't think you would. Someone at the back's nodding, so that's good. So don't worry about that, but later when you start learning a bit more maths, what we do as chemical engineers is we take this slightly more complicated maths, we use it to describe how heat moves around, what we call heat transfer, so conduction, convection, radiation, and then we can use that to design processes. So, you know, if a chemist in the lab gets a test tube and heats it up with a Bunsen burner in a flame, how do we do that at large scale? We don't just get a large Bunsen burner. Yeah, we have to think about how heat moves around, what we call heat transfer. And so all of these things we then use maths to describe. So already you're seeing that chemical engineering is kind of broad. So we've been talking about understanding chemistry and the reactions that happen. Been talking about understanding things from physics, so things like heat transfer. And then we've been talking about how we use maths to describe all of that to help us design things. And what we're actually doing there is we're designing some constraints. What are the constraints on our large-scale process? So as a chemical engineer, I have to understand what can be done and what can't be done. So some of those things we describe mathematically. Some of them are to do with safety regulations. And now we hear a lot about kind of health and safety and why it stops us from doing things. I'm not talking about that. I'm talking about safety in the context of kind of a big chemical process. Who's seen the film Deepwater Horizon? Yeah, a few of you. Do you know what I'm talking about? Mark Wahlberg, and it's about the oil spill in the Gulf of Mexico.
Yeah.
What did you think of the film?
Yeah, it was good.
It was good. I thought it was a bit, as a nerdy chemical engineer, I was watching it thinking it's all wrong. Everything they're saying doesn't make sense. But they made a film, so that was a terrible disaster. So ecologically, the environmental damage, some people died as well, the people who were on that oil platform. And that involved not just chemical engineers, but lots of other types of engineers as well. But the point I want to make is when safety is important in chemical engineering, because when things go wrong, it usually means something's blown up. Okay, so maybe you've seen chemistry demonstrations where they blow things up and it's all fun and exciting. Chemical engineering, in some sense, we never want that to happen. We have to understand all the things I've just been talking about so things don't blow up. If something does, it usually makes the front page of the newspaper, and if it's a really, really kind of severe disaster, then they make a film about it a few years later. But the interesting thing about being a chemical engineer is actually you can do a whole range of things. So you might work on design, you might work, so that could be you sit in an office. So it could be an office job, okay? You could sit in an office and you could be designing bits of a chemical plant that's going to get built in Saudi Arabia. Okay, you'd probably never go to Saudi Arabia, but you'd sit in front of your computer designing, I don't know, heat exchangers or polymerization reactors for a chemical plant in Saudi Arabia. That's one job you could do. Equally, you might be working for Cadbury's making chocolate and being responsible for their daily chocolate production on their chocolate factory, okay? I've been and had a look around. You ever been to Cadbury World and had a look around there? Yeah. Some of the people that you might have seen around there, if you saw some of the plant there, they're chemical engineers too. Okay, so we've gone from sitting in an office to making chocolate. You might work, you know, the North Sea, so off the coast of Scotland, there's lots of gas platforms. You might work on those. I've got a friend and that's what she did. She's a chemical engineer, and after she graduated, she was working off on gas platforms on the North Sea. I couldn't think of anything I'd want to do less personally. But the point is that chemical engineering is really broad. So you might not be interested in one part of chemical engineering and one thing that chemical engineers might do, but there might be another bit that you think, oh, that sounds really interesting, that'd be awesome to do. So one of the things I do as a chemical engineer, I want to find ways of getting all these chemicals and fuels that we get from oil from a different route. And so what I do is I use fermentation, I use microorganisms. So I can take sugars from maybe fruit waste, so things like orange peel, from anywhere. So I can take sugars from those, and I can basically feed the sugar to the cells. They'll eat that sugar up and they'll grow, and these particular cells will also make these little granules of plastic as well, which is pretty cool, I think. So we've got these microorganisms that will make plastic for us. Okay, so the challenge here now as a chemical engineer is how can I get this transformation from sugar to polymer to be efficient enough? At the moment I can do this in the lab, but if I got enough of this plastic to make a water bottle out of it and then put some water in it and tried to sell you that bottle of water, it might be 20 times more expensive than a bottle of water that you can buy in the shop at the moment, just because of the value and how expensive this plastic, this biopolymer is. I'm an academic in Manchester University in the chemical engineering department. I'm the admissions tutor as well, which means I'm in charge of all of our kind of recruitment of students for the future, people who want to study there. You're probably not all thinking about university yet, and that's fine, that's way, way off. But what it's nice to know about, I think, from today is, well, what chemical engineering is and maybe things around you. And you're going to go and read the ingredients on your shampoo and your conditioner and your cleaning products and whatever in the house now and find out about that, I'm sure. So thank you for listening and kind of participating and volunteering answers and not being too shy.